So we'll see one more example on radius of curvature. Okay. Yes. Find rho of the curve xy square is equal to a cube minus x cube at a point a comma 0. Okay. Now here nothing is clearly known that whether this is a function in, this is a curve in y is equal to f of x format or x is equal to f of y format. Okay, I'll just go with the normal formula, and then if I have a problem with it, the first formula I'll go. If I have a problem with it, then I'll think about the second formula. Otherwise, the second formula case is ruled out. Okay, for which I'll be needing y1. Okay, y1 I'll be needing, which is nothing but dy by dx. For which I will assume that this curve equation is 1, and then differentiate equation 1, differentiating equation 1 with respect to x I'll be doing. Okay. So what I will get with respect to x derivative would be 1 UV rule I should use because both x and y I have to take. What is UV rule? U prime v plus UV prime, right? First, I will differentiate u, keep v as a constant, differentiate v, keep u as a constant. Okay, so x derivative would be 1 with respect to x, y squared is as it is, x is as it is, y squared where derivative would be 2y, but since y is a function and x, I have to write dy by dx. In the case of x also, if I write dx by dx, it is 1. Okay. A cube is a constant, so it is 0. And then minus x cube derivative would be 3x squared. Okay, so finally, what would be the value of dy by dx? That's my motive here. So minus 3x squared. Y square I'll bring towards the right. So it would be minus y squared by 2xy. Now, it's a huge term. So since a point is being given, whenever you are asked to find the radius of curvature at a point, first evaluate the derivatives at the point so that they reduce to a number, okay, or a smaller version of it, so that when you substitute, simplifications would be easy. Okay, so y1 at a comma 0, I am doing it. It would be what? 3 into a squared minus y is 0. Similarly, in the denominator, if I put x to be a and y to be 0, I'll be getting something like something by 0, which would lead me to infinity, an undefined value, because of which I'll go back, recheck, and then come up with the second formula of radius of curvature, as I have made a mention in the previous video, that if my dy by dx tends to infinity, I recheck and assume the function to be, or the curve equation to be, assume that x is a function in y. Okay. And then go with dx by dy and d square x by dy square. Okay. Right. Now what I will do, same equation would be there. What is that? Xy squared is equal to a cube minus x cube. Instead of differentiating with respect to x, now I will differentiate. Carefully you should do, because it's not a regular thing and we are not used to it. So you should be a bit careful. That's it. Not a big deal, not a rocket science. Differentiating. Again, I was calling this equation 1 only. Differentiating 1 with respect to y. Okay. So what do I get? Again, I'll be using UV rule, but here dy by dy would be 1, dx by dy would be my x1. Okay, so if I go with x derivative is 1 and I have dx by dy. It doesn't go off, it doesn't vanish off. Here x is as it is, y square derivative is 2y, and then if I do dy by dy also, its value would be 1, dy by dy would be 1. So if I don't write also, it's fine. Or the derivative of y with respect to y would be 1 only, right? So I need not write dy by dy term, but I have to write dx by dy term. I hope I'm clear, right? Yes. This is equal to 0 minus x cube derivative is 3x squared, but x is a function in y, so dx by dy remains as it is. Now I'll collect the coefficients of dx by dy. Okay, so I'll be having what? Y square. If I bring minus 3x squared towards my left, it would be plus 3x squared. Okay, and then those two would be the coefficients of dx by dy. I'll be taking minus 2xy towards the right, so it gives me minus 2xy. Okay, dx by dy, this value is nothing but my x1. This is nothing but 2 minus 2xy by y square plus 3x square. As I have said, when things are very huge and when you are asked to find radius of curvature at a point, substitute the point in the derivatives, first and second derivatives then and there, so that the reduce and your simplification doesn't become complex and you make errors while finishing off the calculations. Okay, so when I substitute x is equal to a and y is equal to 0, my x1 turns out to be minus 2 into a into 0 by 0 plus 3 into a square. Numerator is 0. 0 by anything would be 0 only. So I don't have any problem with handling 0. So I'll proceed with x2 as well. What I will be needing is d square x by dy square is what I'll be needing, for which I'll be differentiating. I'll call this to be 2, differentiating 2 again with respect to y. Okay, so I should carefully do while doing it because I'm having both of them. Okay, yeah. So what I will be getting, I will just write x2 later. Okay, now on dx by dy, once again, if I'm differentiating 2 with respect to y. Okay, again, I need to write again, but I am differentiating. I know that I'm doing it again. D square x by dy square is what I will have. Y square is a constant. Next, dx by dy, I will leave as it is. Y square derivative would be 2y. Okay, plus. Coming to the second term, from each term I have two things. From each term the contribution is two terms. Okay, x derivative is 1. When I am differentiating x, I should be writing dx by dy into 2y is as it is, plus what I will have is x derivative is 1 over. Now next what I will be having is x into y 2y derivative, x into 2y derivative is 2. This is equal to, again I have two terms here. One is what? 3x squared and the other is dx by dy. 3x squared minus is there. 3x squared derivative would be 6x. Dx by dy is as it is. Plus 3x square is as it is. Dx by dy, once again if I differentiate with respect to y, it would be d square x by dy square. Either you collect all the terms or you substitute the point and then finally collect all the points. Finally collect the x2 terms. Okay. Yes. So what I will get will be something like this. Put a comma 0. Put a comma 0 in the above equation. Okay. So yes, I'll be having d square x by dy square at a comma 0. I don't know the value of it. Now y squared is 0. Y is 0, so y squared would be 0. Dx by dy value at a comma 0. I know I have got it to be 0, right? I'll put that in the next step. Into 2y is also 0. Y is also 0, right? Yeah. Dx by dy at a comma 0. 2y at a comma 0 would be 2 into 0, right? Plus 2 into x would be what? 2 into a. This is equal to, there's a minus sign outside, 6 into x is a, dx by dy at a comma 0. I know that's 0, but then I'm writing it for your reference. Okay. 3 into a square into d square x by dy squared at a comma 0. Fine. These are all the things that I'm having. Now, wherever there is a 0, that term vanishes off, this term vanishes off into 0. Into 0, this vanishes off, into 0, this vanishes off, this stays back. This also vanishes off because dx by dy at a comma 0, you can please just see dx by dy here at a comma 0 has turned out to be 0, right? Yes. So what are all the terms that are remaining is 2a is there on the left, there's a minus sign on the right, and then 3a squared d square x by dy squared is remaining. At a comma 0, I have to evaluate it. So I'll just rewrite d square x by dy squared at a comma 0. This would be what? 2a by minus 3a squared. Okay, a and a squared goes off. So I'll be having what? The value would be what? Minus 2 by 3a is what I will have. Is it fine or is there any error? Okay. Yes. So I'll be having what? Minus 2 by 3a. Okay. So these values I'll be substituting in row. What's the formula for row? 1 plus x1 squared whole power 3 by 2 by x2. x2 is nothing but this one. x2 at a comma 0 is this. x1 I know it is 0. Okay. Right? By minus 2 by 3a. Okay, reciprocal of it would be what? Minus 3a by 2. Since it is radius, guys, we just omit the negative sign because your never a radius can be in negative sign. Hence, radius of curvature. I should write the point a comma 0 as well here. Radius of curvature of the given curve at a comma 0 is nothing but is 3a by 2 units. That's how you will write the answer. Why? Because radius cannot be in negative, right? Hence, you will write that it is 3a by 2. I think I am clear with the second formula as well. Okay.